everybody and welcome. Today we are kicking off a mini-series looking at Modbus sensors, all the way from getting them running, getting good data, all the way to sniffing for addresses and fault finding when things go wrong. Today we're getting started with the very basics of just getting a simple sensor up and running. So, picture the scene. You have been a good boy, and for Christmas, Santa has given you a cheapo Chinese temperature and humidity sensor. Obviously, you're excited. Who wouldn't be? But you need to get it up and working and getting good data before you go and show it off to all your friends. Otherwise, you're going to be a laughing stock again. I have a very Modbus-centered childhood. Anyway, first thing we need to do is set the address. And luckily, on this guy, it is super easy. All right, so in terms of sensors, there's generally two different types you need to worry about. There's the type where you can go in and physically flick some switches to set the address that this thing sits at. And then there's the other type where you have to go in over Modbus and tell it what its new address is. This is the former, which is very lucky for a beginning video. So we're just going to jump inside, pull these guys up, unscrew this, and have a look up his kilt. There we go. So we are inside. Zooming on these dip switches so you can have a better view. All right, here we are inside the thing. So you can figure out all of this gubbins over here. The bit that we're interested in is this set of dip switches here. Now, very kindly, they've labeled these starting at the wrong number and backwards. So we need to start counting from this end and count this way in binary. So it's kind of hard to see, but this dip switch here is up. So that's a 1, and all these are down. So we have 1, 0, 0, 0, 0, 0. If you can count in binary, that means 1. If we pop this guy up and that down, that would be 2, 3, pop this guy up, that would be 4. And this is how you set your address with a set of dip switches. So we're going to set the address for 10 for this, which is, counting from here, be 0, 1, 0, 1. Oops, there we go. So that gives us no 1s, 1, 2, no 4s, and 1, 8. So 8 plus 2 is 10. So now the address of this guy is 10. Should say as well, there's no power to it for this. You can do a bit of hot swapping on some sensors. I know for a fact for these ones, they do not like having their address changed when they're powered up. So power off for this guy. And for most of them. As a general rule, power stuff off before you start sticking a screwdriver into its circuit board. General rule for life, really. All right, so we've done the clever end, and now we've got the wiry end. Can be a bit intimidating seeing all the wires coming off of a Modbus thing, but it's really not that complicated, especially this one because there's no actual ground in this one. So we have our red and black, they're our power. That's pretty constant for most Modbus sensors, just red and black for power. And then you'll have any number of colors coming off for the data wires and the signal ground wire. Like I said, there's no signal ground here, so all we've got are the two wires. Sometimes they're labeled, sometimes they're not. Here they are labeled, which is nice, but depending on what you're using to read it, the signal positive, a signal negative, or A plus, A negative, A and B, A plus, B negative. There's a million things that can be called, and it's pretty potluck as to what you're getting and what you're plugging into what, which way around these go. So basically plug them in one way. If it doesn't work, first thing to check is switch round the polarity of these two data wires. Yeah, easy as that really. Power, data. So as always, I have this going into a PLC. This is a 1215C, but that's really not important at all. You can do this into anything that can act as a Modbus master. But the wiring is going to be very much the same, if not identical. So the terminals I have here are M, which is the signal ground, not being used today. Then we have TA and TRA, TRB and TB. Not going to get into what all of these are, but basically, see, this is A and this is B. Ganging them up like this just lets us use some termination resistors to stop echoing. Definitely not needed today. If you wanted to, if you were so inclined, you could just run it on the TRA and TRB lines and forget the TB and the TA lines. And of course, as always, nothing on the RTS because we're in Modbus. One for the eagle-eyed viewers, we have something absolutely hooning away on the transmit and receive lines. So I'll let you guess what that is. Alrighty, so for the uninitiated, we are in a completely blank build. And what we are going to do before we do anything is set up our memory bits. Look at that. It's like I've done this before. So system and clock memory. Probably going to make use of these in this little mini series. So I'm going to set this at 1000 and set this guy at 1001. I go into this in way more depth in a couple of other videos, but this basically just gives you some stuff to play with as you're going through your program. Good. So now that is set, that's all we really need to set up to get this working. So we have our main, obviously nothing in the main at the minute. What we're also going to give ourselves is an organizational block for startup. So now you can see we have the main, which will do the majority of our programming, and startup. Inside of startup, we're just going to pop one of these communication packages inside of communication, go to Modbus, mbcom load, drag and drop it there. I'm going through this pretty quickly. If you want a more in-depth breakdown, have a look at the Modbus backwards and forwards video that I've done. Because this is only ever going to run right at the start, we can just put a always true in here because this will only run once, so always true is fine. And because we've set up those system bits and clock bits, we can actually put that there. The port, double click on him and then find this guy here, the CB1241. I have the CB and the CM. Not using the CM for the moment, so we'll pop it on the CB. Baud rate, I know for a fact this is 9600. We'll come to ways of working this out for different sensors later on. Can't change it on this sensor, it is just legit 9600 with zero parity, etc, 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 all of the industrial standards. And this, we don't have anything to put in here yet because we don't have the data block for that. So we're going to come into the main and we're going to give ourselves one of those data blocks. Back into communication processor, Modbus. We're running the PLC as a master, so we're going to drag and drop master into here. Easy. Request, I'll come to in a minute. Modbus address, we've just set that physically on the device, so we can hard code that in as 10. The mode, again, I go into this in more depth in the other videos, but we're reading. So our mode on a Siemens PLC is 10, which will put all of the right codes in actual binary that gets fired down the line. The data address and the data length. Again, we're going to come into this in more depth in later videos. Like if you don't know these and you just have a sensor you need to get working, how you can work this out. But for this video, it's just a given that our data address is 40,001. And the data length, I just know, is 2. Again, we'll come on to how you can work these out if you're not given them from the supplier. Data pointer, we'll get to in a minute, but now we've created this master, we can link it back to the startup block in startup. So this is on DB2, so we'll just make sure that is actually looking at the right thing. So we come back to our startup block inside of here, start typing Modbus. Here we go, Modbus master DB2. Click none, make sure it gets rid of that dot, press enter. Everything is happy. If we wanted to go overkill, we could add everything here, but we don't need to. So that is our startup function done. We can close that. Back in the main, our data pointer is the only thing that we don't have here. So I'm going to make what I usually do for these things, a database to hold information around the Modbus criterion. So make a data block. I'm going to call it Modbus config. Does what it says on the tin. Okay, and before we go any further, this was one of the major learning points from my other video. This is something you have to do. You need, wherever this guy is pointing, so I can actually point it to it already, which is the confusing bit. There we go, Modbus config, point to there. Oh no, we can't point it there yet because we haven't created it. The array inside I'm talking about. But what we do need to do is come and go to properties, and we need to turn off this optimized block access. If we have that on, we can't use it for this Modbus communication stuff. So now we've done that, we need to create an array inside of here that will be our place in memory that information from the sensor gets sent to, and if we were talking to anything, where we would put information to be sent out. So we're just going to call this data. Data type is an array of integers. And for the fun of it, I'm going to make it 5 long. There we go. So now we have, sorry, that would be 6. 0 to 5 is 6. So we have an array of integers and it's 6 integers long. Also inside of here, I am going to create just a couple of flags for ourselves for future programming stuff. So I'm going to create done, which is a bool. I'm going to create busy. I'm going to create error. And error code. We won't use these in this video, but we will use them in future videos. The error code is a word. So now we've done all of that, we can come back to our main and start plugging these up. So we have the data pointer. That data pointer is going to point to this array in the Modbus config. And now we have unchecked optimizing block access. That will actually work. So inside of Modbus config, in the data, I'm not going to put it to a particular one. I'm going to click none. So it's just going to that array. Press enter. Everything looks good. And then we can drag and drop these guys onto here. Future-proofed. Also what I'm going to do is I'm going to be a bit cheeky, come in here and pop in a normally closed and assign that to busy, and then link that into the request. So basically, if you saw the intro, this is just going to be running like Billio. The millisecond that if this is not busy anymore, it will allow it to send another request. So no rest for the wicked. But there we go. We're pretty much set up to do everything we need to do. So let's get this thrown up to the PLC. Okay, so that's all up on the PLC. We can come up and have a look at how the program is doing. Obviously, this is going to be a vastly different experience for you if you're not using a Siemens PLC, you're just using something else as a Modbus master. This video is kind of half for Siemens, half for Modbus. So you can see busy here is just on. It is running like the clappers. No errors, which is always good. But if we come into the Modbus configuration things and see what is going on here, again, we can see busy is just pretty much flagged as constantly true. No error codes, no errors. everything is good. Inside of data, which is where the interesting stuff is happening. 561 and 229, and then a bunch of zeros. Well, the zeros make sense because we have only said we want a data length of 2, so we would only expect 2 things out in that to come into this register, so that makes sense. But why do we have 561 and 229? Well, this is because we just send integers over Modbus. And I know, again, we're going to get into a bit more depth of how to fact find these when you don't have data sheets and things like that, which is quite common, especially because we're out in Saudi Arabia. The majority of the sensors that we get through are from China, very poor documentation, so we have to do a lot of fact finding of our own over here. But we'll get into that in future videos. What these two numbers is a multiple of a floating point number. So what we need to do before we can actually use this to make decisions or throw up to the cloud, up to AWS or to the HMI or anything like that, we need to convert from these integer values into a floating point number. And I know for these sensors, you just divide by 10. So spoiler alert, the humidity is 56.2 degrees. And the temperature is 22.9 degrees. You just divide by 10 for this particular sensor. But let's look how we do that in the code to actually be able to use that for programming. Like, what if you wanted to put this into an automated program that only started a function over 22 degrees? Well, this is definitely over that at 229. So let's have a look at that now. I'm going to come offline. And what I generally do is actually have a separate file for the real data, but I'm just going to pop it in Modbus config. I'm going to put real temperature and real is an actual term in terms of data types in Siemens. Real, same thing as a floating point, and real humidity. So they're both real numbers. All we need to do now is a bit of maths. Math. And we are going to divide. Where is he? There we go. We're going to divide the first point in this array because we know the first point in this array is always going to be humidity. So humidity divided by 10, and pro tip, this is looking automatic. You can set it to be just absolute, but if I pop in 10 here and then try and output this to the real humidity, looks like it's going to work, but this will actually force this real humidity to be like 10, 11, 12, like an integer number. It won't let you do things like 12.5 degrees or whatever. So you have to come in here, and this divisor, you just need to be explicit and put 10.0. And now we've done that. It still hasn't gone there. Okay, well it didn't change itself. So we're just going to change that to real there. And we're going to echo this, just copy paste. Change this address to 1 because we know this first point is the temperature, again dividing by 10, and we're going to output to the temperature. So throw this up on the PLC, then we'll go online and we'll see what these are looking like. Lovely stuff. So that's all up. We can see our ladder logic seeming to work okay. You can see it moving through there nicely, and in the config file, if we monitor this, we can see the real temperature 22.9 degrees C and the real humidity 56.2%. So it is that easy. You can now show this off to all of your friends and have a very Merry Christmas. In the next video, we're going to be looking at how you start finding out some of this information if it's not given to you in a data sheet. Like, how did I know to start at 40,001? How did I know to look at these two addresses. So that would be 40,001 and 40,002. What happens if we don't have the address? Yeah, all of these things that you just run into in real life, but you generally just have to work out on your own in the field. So thank you very much for watching, and I'll catch you in the next video.